Assalamualaikum and a very good day to everyone. We are group 2 from section 23. So today we're going to learn chapter 7, which is matrix algebra. This chapter consists of 5 different subtopics, which is elementary row operations, determinant of a matrix, inverse matrices, system of linear equations, and eigenvalues and eigenvectors. But in this video, we're going to focus on elementary row operations. So, what is elementary row operations? It is an important method to find the inverse of a matrix and to solve the system of linear equations. The following notations will be used while applying ERO. So the first one, interchange the I row with the j row of the matrix. This process is denoted as Ri interchange with Rj. Secondly, multiply the I row of the matrix with the scalar k, where k is not equal to 0. This process is denoted as Kri. Lastly, add the I row that is multiplied by the scalar k to the j row, where k is not equal to 0. This process can be denoted as Kri plus Rj. The purpose of this process is to change the elements in the j row. So basically, these are the only operations that are allowed in elementary row operations. So now, let's take a look at different examples. So for the first example, we're going to be taking a look into this matrix right here. We're going to reduce it using elementary row operation and turn it into REM. So the first thing is to just rewrite this matrix right here. Okay, the first step is to find a leading one in this position right here. But according to the elementary row operations introduced just now, we can just easily interchange between these two rows so that this one right here plays into this position. So the operation that we can use is R2 interchange with R1, and we will get this matrix right here: 2, 5, 3, negative 3, 1, 2. Just let the third row remain the same. So now, after we found this leading one right here, the next step is to make sure the numbers below the leading one turns into 0. So let's turn this number right here into 0. The operation that we can use is negative 2R1 plus R2. Let's rewrite the first row and the second row, the third row. And let's calculate the second row. I will get 0, 1, 1. So now, let's turn this number right here into 0. The operation that we can use is 3R1 plus R3. Make sure to always put the row that you're going to change on the right hand side, right here. And always make sure to use the leading one above it, which is the first row. So let's calculate. First, we need to rewrite the first and second row. Okay, let's calculate the third row. I will get 0, 7, and 5. So now we already found this leading one right here. Next step is to just reduce this number or turn this number into 0. The operation that you can use is we just times the leading one by negative 7 plus the number below it. Since we do not have enough space right here, we need to start over from this side. Never turn it into a flowchart. So the operation that we will use is -7 R2 plus R3. Let's rewrite the first and second row and calculate the third row. I will get 0, 0, -2. So now we're going to be turning this number into a leading one. Basically, we can just multiply this row with -1 over 2 R3. Let's rewrite the first and second row. This number is 0, 0, and obviously we get 1. So we have successfully turned or reduced this matrix into REM. Basically, this is our final answer.
For question number 2, it is given that the matrix be 1 to 1, -1, -2, -2, -1, -1, and 0. We need to perform an elementary row operation ERO consecutively by the order with R1 plus R2, R1 plus R3, R2 interchange with R3, and -R3. This is the orders. So for the first step, we copy the matrices given, which is 1 to 1, -1, -2, -2, -1, -1, and 0. Make sure to copy it correctly so we didn't make a mistake. And so to complete the first order, which is R1 plus R2, we need to take a look at the first row and second row. How to get the numbers? We need to know that R2 will change. So take the number from the first row, which is R1, and then insert in the equation in the order 1 plus minus 1 equal to 0. And then we take this and takes this 2 plus minus 2 equal to 0, and this one 1 plus minus 2 equals to -1, which is the same, which is the answer. And for the second order, R1 plus R3, we need to do the same just like the first order. R1, which is 1 again, and R3, which is -1. We will get 0, and then 2, the second one, 2 plus minus 1, we will get 1, and then the third one, from the first row, 1 plus 0 equals to 1, and yeah, it will be the same. You will get the same value. As we got the second part, we will move on for the third order, which is R2 interchange with R3. So for this order, the second row will change their position to the third row, and the third row will change their position to the second row. So it will become like this. Their position has changed, and then next we can move on to the fourth order, which
is negative R3.
as we know, row 3 that will only change, so 0 and 0 remain, and then the negative 1 here will become positive. So this is our final answer. So our final answer would be 1, 2, 1, 0, 1, 1 and 0, 0, 1. Also 1, 2, 1, 0, 1, 1, 0, 0, 1 is also known as row equivalent matrices because it consists of at least a non-zero row, and each of them has the leftmost non-zero entries in every row is 1, or also we can call this as leading one, and the leading one in the lower row occurs to be farther to the right than the leading one in the upper row, and it also consists of entirely all zero, which is grouped together at the bottom of the matrix, so that's why it's REM.
This is Sarah, and next we are going to be proceeding with the next examples, in which I will be performing the elementary row operations to achieve our REM, which is row reduced echelon matrices. So as usual, we have to see our leading one, and here we can see that in our example we already have leading one in the first spot, therefore we don't have to do anything to change it. And so our next priority will be these two numbers below it, and we have to change them to zeros. So the way we can do this is by using the other rows. And here I see that we can use negative 2R1 plus R2. As usual, we put the row that we want to change at the back of the equation in order to not confuse ourselves. By using this, let me just write down the numbers that are unchanging, and the row that changes in the middle will become 0, negative 3, 3. We reach this as usual by performing this equation and changing it up on the second matrix. And next we will proceed to the second step, in which I have to change this negative 1 to a 0, and so we write down the numbers that don't change first as usual. And as for the third row, we will be using the equation R1 plus R3. And here we can see that we will gain 1 minus 1, which is 0, 1 plus 2, which is 3, and negative 1 plus 2, which we will get 1. Next, we have to look at this 3 right here, because this is the first number that you will encounter, and it has to be a 1 in order to become an REM or an RREM. Here, we can actually do the operation negative 1 over 3 R2. Usually, we will try to avoid, as we don't want any fractions, preferably in our working. But here you can see that we will actually get 0, 1, negative 1, which means that we don't actually have fractions, even though we used a fraction as the equation. So we can actually use this fraction if you see that it's suitable for the moment. And next, we want to change this 3 and this 1 into zeros. We can do this by putting in the equation negative 3R2 plus R3. Okay. So our next priority will be changing this 1 into a 0 as mentioned before. We can do this by performing the equation negative R2 plus R1. By doing this, you will have to change the first row. You will get 0 plus 1, which does not change the one that you want to leave there. Meanwhile, you will get a 0 here as desired, and on the third column, you will achieve another 0, which is again very ideal. Next, our operations should be changing this 4 into a 1 as we want it to become a leading 1. And so we can perform the equation 1 over 4 R3. Once again, we are using a fraction because, as you can see, by using this fraction, it doesn't actually change the other numbers in the row because the rest are zeros. And so we proceed to gain 0, 0, 1 on the third row. And here you can actually see that we've already achieved our EM. However, we actually want to reach our REM at this point. So we have an extra step right here to change this -1 into a 0. So we can do this by putting in R3 plus R2. And this will give you an RREM matrix. There you go. This is an RREM. As you can see here, in the REM part, you already have an REM because you have 3 leading ones that go down in a staircase type of style. And this actually brings no problems when you want to call in an REM. However, here in this question, we're trying to find our REM, which means that we have to actually make the rest of the numbers zeros.